So our learning goal for today, first of all, let's take a quick look over here. I can use proportions to solve problems involving geometric figures. So we're still going to do what we were just doing back in lesson 1.8, but now we're carrying it into another way we can use it, and that is when we have to solve missing information from geometric figures, we can use a proportion model to do that. So let's talk about similar figures, because when we have similar figures, that's when it's really handy to be able to use proportions. Anybody happen to know the definition for similar figures? What it means? One figure is similar to another. What can we say about them? They're the same, but not exactly the same. Okay, so what is the same about them?
The same shape.
They're the same shape. Okay. Well, if they're the same shape, what would have to be the same in them for them to be the same shape? What do you think is the same then, if they're the same shape? Pardon? The way they look. Well, what makes them look the same? What makes another square like another square versus if I compare a square to just any old quadrilateral? What's true about their angles? They're 90 degrees. So for a quadrilateral to be a square, it has to have 90-degree angles. And so if I have a square and then I have another square, would they be similar to each other? Do they look the same? Do they have the same shape? Yeah, and so it's the angle measures that makes them the same shape. But what they don't have to have, so let's fill in that part. Similar figures have exactly the same shape. And what makes them have the same shape, this is not in our notes, but I want you to put this here. What makes them have the same shape is the fact that they have the same angle measures. But you said to me, they have some things the same, but other things not. What's the other thing then that they could not have in common? Could one square be bigger than another or smaller than another? Yeah. So, but not necessarily the same size. Okay? So they don't have to be the same size to be similar, but they do have to have exactly the same shape. And one thing that you're going to hear a lot and you need to have an understanding of is corresponding. We have corresponding sides and we have corresponding angles. So when we talk about corresponding sides and angles of similar figures, we are saying those are the ones that are in the same relative position. They're kind of in the same place in each of the figures. So if I ask you to go to the back right-hand corner of my room, and then I ask you to go to the same, some of you, I ask you to go to the same location, but now over in Mrs. Van Bruggen's room, where should the people that I send over to Mrs. Van Bruggen's room go if I say go to the same location? Where should they go? Well, they need to be in the back right-hand corner also. So they would need to be on the other side of my wall here. Is that what you're pointing to? Yeah, they would need to be in the back right-hand corner of her room to be in the same position. Those are corresponding corners of our rooms. They're in the same relative position of the rooms. When stating that two or more figures are similar, this is how you're going to know if they're telling you that they're similar, is this symbol will be between them. So put that little squiggle. That means is similar to. Is similar to. So when they have that between two names of some figures, they're telling you those guys are similar figures. Even if you don't have a picture to look at, they're telling you that those figures are similar and you can draw your own picture. Okay, so right here, I want you to put a box around this so we don't forget about this. This is important. It's like our directions. To find the missing lengths in similar figures, you must know which sides correspond, which sides match up, which ones are in the same relative position. You can use their letter names to help you match up corresponding sides. And the reason I say use their letter names is because when they give them names, that's how they name them. Their corresponding parts are in the same location in the name. And when you get the picture, they're not always necessarily sitting in the same position, each of them. One of them might be turned a different way, and then you gotta be able to tell which sides match up. So we're gonna set up ratios of corresponding sides, replace the names of the sides with their lengths when setting up a proportion. So the first thing we're gonna do is we're gonna set up a proportion showing the names of the corresponding sides. No numbers are gonna be involved in our first proportion, okay? So let's look at this one right here. We're supposed to find x. Let's circle that. That's the one we're looking for. So find the value of x. So above that, I want us to put, that's really the length of side EF. Okay, would you put that above it? That's really the length of side EF, the one that we're looking for. So we really need that one for sure in one of our ratios, in one of our comparisons. So we're going to look for, so put EF, not x. We're going to look for which side do we think corresponds with that one, and that's going to be downstairs in our ratio. So we look at the other triangle, triangle ABC. Which side do you think corresponds with side EF? From the triangle ABC. Is it side AC, or is it side AB, or is it side BC? BC? Okay, so let's put that here for right now. We think that EF corresponds with BC. They can be compared to each other. Okay, here's how we're going to double check ourselves to make sure that we're right. We're going to go up to the name, and we're going to look at where EF is in the name. EF's right there. So BC should be in the same position in the name. Is it? The last two letters in each of them, isn't it? So they are corresponding sides. Okay, then now we'll set up another relationship of corresponding sides. So we got, the good news is we got 5 other pieces of information. So we get to pick which other sides we want to deal with. But we need upstairs in our other one, we need to have, aside from the triangle that we started with here, we started with the first triangle, DEF, upstairs, so we have to have something from DEF upstairs in the other one. So give me a side that you want to use. You want to use the 9.1 or do you want to use the 13? Do you like decimals? Do you like whole numbers? Should we do 13 then? Okay, so let's use DF. Remember, we're just doing names right now. DF is the side that we're now going to figure out what side corresponds with that in the other triangle. So which side do you think corresponds with side DF? So here's our DF right here. Which side do you think corresponds with that from the other triangle? AC. Are we in agreement? Okay, let's put it there, and then let's do our double check in the name thing. Okay, so D is the first letter, and F is the last letter. A is the first letter, and C is the last letter. Does it seem to work out? Yeah. Okay, so now we can feel pretty confident that we have a good proportion model set up. So now we'll replace numbers and the actual lengths of them. So EF, how long is it? How long is EF? What do we call it? It's not a number, it's X, yeah. How long is side BC? 12. You got your paper in front of you. You can look there. It's probably easier to look there than up here. How long is side DF? 13. How long is side AC? 10. Okay, there's our proportion ready to solve. We will do what we have to do to get X. So anybody want to suggest what we would do? This is coming right now straight from lesson 1.8. What should we do? Okay, X times 10, did I hear, Sam? And 12 times 13. That is our cross products. Yeah, there's our cross products. So we're just, doing like we did last lesson. X times 10 is 10x. 12 times 13 is 156. Okay. I'm going to have to move over here. I've kind of run out of room, so now I have my 10x equal to 156. What are we going to do next? Divide by 10. Okay, divide both sides by 10. And we're going to find out that x equals 15.5? 15.6, I think, right? If it was 155, it would be it'd be 15.5, but it's 156, so it's 15.6. And what's its label going to be? Feet. Yeah, those are feet. Here we go. We make sure we get labeled. When we know what our number is representing, we label it. Okay, I want you now at number 2. Here's all I want you to do, and I mean this. All I want you to do at number 2 is set up the proportion with the names of the sides in it only. There should be no numbers in your proportion when Mrs. Creviston or I look at your paper. So go ahead and in number 2, you try to set up your own proportion with names. So we're looking for X, which is right here. First of all, we're going to give it its name, which is, I'm going to say dy. Okay? So you got to have dy in there. That's what we're looking for. So again, remember how you can double check to see which sides are corresponding? You can use the name to help you make sure you did a good set of corresponding sides. Okay. Who's ready to come put theirs up on the board? And willing. Come on up, Maisie, you can put yours up. The rest of you keep working if you don't have it yet. If you have a different one than Maisie, you can come up and put yours up next. And we'll check out all the ones we have so that we make sure that we have ones that will work before we start substituting numbers in for them. Okay, there's Maisie's. Anybody have the same one as Maisie? Which is dy over nt equal to Ly over gt. No one has that one? Okay, then let's see another one. Come on up. Hurry up. Let's go. Maisie wrote kind of big, but we'll change the color and give you the over here. You get to do yours there, Andrea. Anybody have Andrea's? Now, you have the same one as either of these ladies if your letters are just turned around. Like if you call DYYD, that's okay. It's really the same thing. So if you have LY as YL, it's really the same thing. So do anybody have this set of corresponding sides? This is how you did your ratios, your proportion. You did, Blake? Preston? Anybody else? Okay, then we got, sounds like some more choices here, huh? Okay, come on up. Who's got the next one? Right here, under the green. What's the other one then? If you don't all have one of these two, then you gotta come up and give us what you have. Come on. It's good to explore. I mean, it's okay to be wrong. It's safe in here. I don't take your lunch hour away today if you're wrong. Okay. Right with your finger. It's already green. You're gonna have a green proportion. Is that AT on the bottom, all right? Yeah. Okay. Okay, anybody have Sam's? We got everybody covered yet? So, okay, who's gonna come next then? That's gonna be in black. So there's some room for another one. Let's go, You're using it one more time, but if you don't have one of these, you get up to the board and show us yours. Take paper up with you. Go. This is how we're going to make sure that we know how to set them up properly. If I just do it every time for you, with you, then guess what happens? One or two of you catch on, and the rest of you are still wondering what's going on. so that's an E, N-E, okay, thanks. Just to get rid of a little bit of confusion, I'll just do that. Okay, anybody have Samuel's? Take a look at his. Those of you that didn't have one up there yet, or did use Matt Samuel's? So there's still other choices out there. Huh. Okay, who's coming in? Okay, you're going to do it over here on this side in black. So I'm either eventually going to have 8 different things up there, or some of you have the same as somebody else does. Okay, so fine, yours is there. Okay. Okay, so how many for Sydney's here? Sydney and Seth and anybody else? Okay, there's 2 of you. Okay, how many for, this was Maisie's. Anybody else have Maisie's? So you do, just 2 of you? Okay, 2 there, now we're up to 4. Okay, whose is this one, the red one again? Andrea's. Andrea Preston and Blake? All 3 of you agree on that one? Okay, and how about this one? Whose was this one? Yours, Sam? Anybody with Sam? Okay, and this is Samuel. Anybody with Samuel? Okay, so these better add up to 8. 2, 4, 5, 6, 7, 8. Oh, now I'm up to 9. Oh well, that's okay. 5, 6, 7, 8, 9. Oh, there are 9 of you in here. Sorry, there's 2 of you at this table. Okay, there are 9 of us. Okay, now we need to explore and see which one's right, or how many of them are right or useful to us. Okay, so let's start right here with Maisie in the beginning. Okay, dy over nt. dy corresponds with nt. And why do we want dy? Because that's the one we're looking for, isn't it? Okay, so dy nt. I'm feeling pretty good about that. So all these other ones that have dy over nt, those are good choices, aren't they? Okay, a good relationship to set up. Then the other one that Maisie had, she says that ly over here, this one, corresponds with gt. So I'm going to go and look and see. I'm going to go and see if that works with the name. So ly is the first and the last, and g and t are the first and the last. So that's a set of corresponding sides. But what's the problem with that? dy is the one we're looking for. So it's already our unknown. Can we have another unknown in this problem? Do we know what ly is? Do they tell us what ly is? No. So even though this is a good setup, it's not going to be useful to us because it's going to have an unknown here and it's going to have an unknown here, and we can't have 2 unknowns in a proportion. We can only have 1. So even though this is a good setup, it's not good for solving our problem. Okay, let's take a look at, I don't know who was next, but we'll just move over here. So we already decided that's okay. AD over NE. So do these come from the same one? It's got to come from that one. So do I have a good setup there? Do we have what? AD and NE. Even though it's EN in the name, is NE the same? Okay, so that's a good setup. So AD, do we know the length of side AD? We do. Do we know the length of side NE? We do. So should this one work? Yeah, okay, so check. We like that one. Okay. Well, let's just see now then, so we already decided that AL, so AL, that's the first 2, EG, that's the first 2. What would be wrong with AL? Do we know AL? No, we don't know it. This is another unknown. So we got 2 unknowns in this one. We have a good setup, AL and EG, but we have 2 unknowns. Okay? Let's go down here to this one, to your Sam. Let's see what's going on there. We have EY. Well, there's not even an E in this one, is there?
No, this is correct.
Oh, so it should be what?
This should be ET and AY.
ET and AY. Okay, so ET is from this one, but yet we started with this one upstairs and the other one. Okay, so these would have to come around this way. So now we're going to have AY upstairs, which is, oh, there isn't even a side AY. Look at there. There isn't even a side AY. Yeah, they have to be one. They have to go from one point, one name to the other. Okay.
Right.
So we have to throw that one out. And then this one, can we keep this one? LY. We don't even have. What's missing in this? What's missing in this one? Why can't we have this one? What's missing in this right here?
dy over nt.
We need the dy because that's what we're looking for. Okay, everybody, we gotta use this one, right? Which one is it? This one right here. Okay, everybody, erase the one you have, and this is the one we're gonna use. So dy over nt equals ad over ne, or en. Okay, now substitute. Let's substitute our numbers in, okay? So, good job, class. Way to, I went and erased that, and now I gotta figure out what it said. So you're gonna tell me again? Whose was that? That red one? Okay, thank you. Okay, so it was what?
Y over nt equals AD over NE.
What was it? AD
Over NE.
over NE. Okay. Okay, so dy is our x. NT is what? 3.5. AD is 3.5. And NE is 2. Okay, so basically, guys, what we're doing, there's our dy. We used, and upstairs in the other one, we used our 3.5. In this one, we used our 3.5 and our 2. Okay? So, cross products and solve. Go ahead and do your cross products. As long as they both, so did you use the small quadrilateral?
Put the ne on top.
But what's in top on the other one then, Blake?
Dy.
It can't be that way then, you can't do that. Even if you say you get the right answer just because the numbers work out this time, you can't do that. Okay, you agreeing with me so far? And we're not going to ditch anything because it's a terminating decimal. We'll leave the whole thing there. And what's the label going to be on our number answer? Centimeters. These were measured in centimeters. Okay, I'll leave that up there for you to compare when you're done. So, you know what? You can do a whole bunch of work for nothing if you don't have a good setup. That's why I took so long on one problem to talk about just getting it set up. It's that important. You have to have a good setup, just like we talked about back in the last lesson. When we set up our own proportion models, they have to be good comparisons. We don't compare boys to girls in one ratio and girls to boys in another ratio. We don't compare from one triangle, we put it upstairs in one ratio, and that same triangle, we put it downstairs in the other. We can't do that. Those comparisons have to line up properly. Okay? So anybody need this up very long or have questions? You want to have good notes? Okay, let's go to the back side then and do some more practicing. Do I have someone who needs to leave? I'm kind of feeling a little negativity going on. Okay, let's go to the back. Find the value of x in the diagram. Okay, what's x's name? What happened here? I don't have that sheet. Okay, what is x's name? RS. It's right here, isn't it? RS. So let's start with that. That one has to be in our proportion, doesn't it? Has to be in there because that's the one we're solving for. So let's just start right away. Let's say, you know what? RS has to be in our proportion. So what side does RS correspond with? From the other triangle. The what? QR. So this one right here. Okay. Let's double check in the name. Okay, let's double check in the name. RS is right there. In the other one, QR, ooh, are they in the same position in the name? So then that means they're not in the same position in the triangles either. So which one should it be instead of QR? It should be RV or VR, yeah. Okay. I like to keep it the way it is in the name, so I'm gonna go back to that. Okay, so we took from the first triangle, the smaller triangle upstairs in the other ratio, so we gotta go back to the small triangle. Well, what would be a good choice for the other ratio? Should we pick this side, RT, or should we pick ST? Why ST? Because you like S is better than R's? Because it tells you how long it is. That's going to be an important one. So we're going to use ST. And then ST corresponds with what side from our other triangle? QB. Yeah. So do you have to do this in your homework? What do you think?
So,
Guess so. Yeah, you do. You're going to show that you can get a good setup with names first of corresponding sides, and then you'll start plugging stuff in for them. So X is our RS, our RB is 10. What's our ST? That is 3.6. And QB is 6. Okay. Good setups, then good substitutions, and now this is the old hat. Solve your proportion. Either cross products or you come up with another way that works every time. And in the end, we should get the same value for X, and then we all need to give it a label. So, what's our value for X? 6. Okay. Or what were the sides measured in? Centimeters. So this would be 6 centimeters. Okay, questions on that one at all? Okay, then let's do like we did. I'm not going to make everybody come up to the board, but I want everybody to try and set up their own name one. Your own name one. So remember, the first thing you decide is what are we looking for and what's its name as a side. Because that one has to be in your proportion. Okay, so all we're doing, we're just getting the name model, and then you're going to share it with me. So I'm starting with a DC, and you're going to help me out. Or a CD. Okay, give me a proportion model that we can use. I want my DC, or also known as CD, I want it upstairs in my first ratio. What should I put downstairs? EB, okay, or BE, doesn't matter, either way, okay? EB or BE, okay, and then how about the other one? What would my other one have in it then? DE? Okay, you know what might be helpful for you on this one? Is to take this big triangle and then draw the smaller triangle because I disagree with you that there's a side DE that is the side of a triangle, okay? So, you want to try again? D what? DA. Okay, so DA coming from the big triangle like it did on the other one. Big triangle upstairs, big triangle upstairs. DA corresponds with? DA right here corresponds with EA. Okay, and let's go verify it in the name. DA first and last, EA first and last. Sounding like a pretty good setup. Okay, now let's start substituting. What are we going to put in for DC? X. What are we going to put in for EB? 5. Okay, so this is X, this is 5. We all agree so far? What are we going to put in for DA? 12. Where did you get 12? I don't see a 12 in the picture, Preston.
Because you add the 8 and the 4.
Oh yeah, these have to be added together to show how long that whole side is of that bigger triangle. Good job, Preston. So 12 over, how long is side AE or EA? It's 8. Now this is 8. So there's our proportion. Now we can solve it. That came from. So how long is our side X, also known as side BC? 7.5 or 7 1/2. You can give it either way. They're the same. 7.5 or 7 1/2, and the label is, this one happens to be centimeters also. Okay, there we go. Now, let's just take a moment to go see if our answer makes sense. Does it seem reasonable? How do you feel about this being 7.5 centimeters? Does that seem reasonable? Why? Why is it reasonable? Because you like 7 1/2? One of your favorite numbers? Oh, no, I always like the numbers. Why is it reasonable? Because the math worked out? No, not because of that. What's that? Because it is. No, that isn't good enough either. Oh, good job. Good luck in job interviews. How do you feel about, like when, and then you say, and they ask, and you say, just cuz.
I've said that before.
Have you done that? Yeah. Well, good luck getting that job. Okay. Why is it reasonable to have a 7 1/2 centimeter length for X for side DC? Because what? You're making this way too hard. Should it be shorter or longer than this side? Oh, longer. Is 7 1/2 longer than 5? Well, then I'm feeling like it's fairly reasonable. If I would have ended up with something like 4 as my answer, would that have been reasonable? No, that would have said it was shorter than that side, and that side is 5. So reasonable just means, look at it and say, well, wait a minute. Can this be possible? That's what reasonable means. Okay? Okay, let's get out a sheet of loose leaf paper.